Sorry for the delay. Okay, let me quickly start the class. I hope you are all practicing the problems. The same problem today also. I'm not able to. I shared the video with PPT, but it's not showing. Yeah, you can see the screen, right? Can you see the screen? Okay. So in the today's class, let us discuss about the probability distribution. So to understand probability distribution, let us first understand what a random variable is. A random variable is one that can take a number of different values. For example, you will say whether it will rain or not. It's a probable. We cannot say it as an exact event. It may rain or it may not rain. That means that particular action can take two values, either yes or no, right? This is called as a random variable. When you toss a coin, it can be head or tail. When you roll a dice, it can be 1, 2, 3, 4, 5, or 6. Right? So here the random value variable has 6 values. When you toss a coin, the random variable has two values. When you say whether it will rain or not, the random variable will be having two values. So that variable which is included in the probability of our discussion is called random variable. Why we say random is that it is not exact, it can take any value. There is no hard and fast rule that why this has come, why that has not come. We cannot judge like that, right? A random variable is one that can take a number of different values, but it is not possible to know which value it does take until some experiment is performed. And when you toss the coin, also you cannot say whether you will get head or tail. Only when it falls on the ground, you see, then only you can say it is head or tail. Usually, the experiment takes the form of drawing a sample from a population. That means so many items are laying on your table. You are just picking one. Till you pick one, you cannot say which item you are going to pick. Flipping a coin, rolling a dice, and taking a sample of 600 households are some of the example. Out of so many houses in Bangalore or in Mysore, I am taking 600 houses for my survey. Which 600? Right, I cannot tell it right now. In other words, a random variable is a description of the numerical values that the outcome from an experiment can take. Like the ordinary variables, randoms can be classified into two categories. One is discrete or continuous. That is, discrete means, say for example, When you say it will rain or not, yes or no are two different things. So it is discrete, right? How much time it will take to go to your home from office, then there is a range is there. You can say I usually take 10 to 20 minutes. Within that 10 to 20 minutes, any value can be okay. It can be 15 minutes, it can be 16 minutes, it can be 16.5 minutes, like this. Then it is a continuous random variable, right? Sometimes it can be discrete, that is one or two, like that. Okay. Now let us see what probability distribution is. Distribution means we are representing the random variable values in the form of a table, for which we call it as the probability distribution. Probability distribution means the probable chances of different events put in the form of a table. For example, you toss two coins at a time. You can get both the heads, first one head, second one tail, first one tail, second one head, or both the tails. Now, if you ask me, the probability of getting the head is probability of getting the head 0 is how much? It is 0.025. Probability of getting both the heads is how much? It is also 0.025. Probability of getting one head, because two chances are there, HT or TH. Total choices 4. How do you calculate the probability? In case I say both the head means HH. There is only one HH out of 4. So it is 1 by 4. 1 by 4 is 0.025. Zero head means both tail, TT. How many TT are there here? Only one TT out of 4. So 1 by 4 is 0.025. And uh, at least one tile. There is one more thing. Getting one tile. Getting one tile is HT or TH. That is 2 by 4 is zero point 0.5. Now, what is the probability of getting at least one tile? What is the probability of getting at least one tile? Can anyone of you say that? What is the probability of getting at least one tile? Yes, Sahana Shetty 0.75 is correct. 3 by 4. Yes, Lakshmi, you are right. Shilpa, you are right. At least one tile means either one or two, right? It can be at least one means if both are tile also, it is also okay. So not 0.25 Gagana, it is C. You are taking HT, TH, TT. All the three are okay. When I say at least one tile, then you are getting 3 by 4 or 0.75. Okay. Now, getting both the head or getting both the tile or getting one tile, I have put the probability here 0.25, 0.5, 0.25. If I add all this, how much do you get? If you add all the probability here, how much do you get? Yes, you are getting 1. When you get 1, then we call these events as mutually exclusive events. Mutually exclusive events means if one event is not is happening, other event cannot happen. Then we call it as mutually exclusive event. If you are getting both the head, then probability of getting both the tail is ruled out. Probability of getting at least one tail is also ruled out. So all these four are mutually exclusive event. Mutually exclusive event means if one event is happening, other events cannot happen. Now, if I say what is the probability of getting at least one tile? Okay, what is the probability of getting at least one tile? Then what happens? See, okay, fine. Uh, at least one tile means it can be HT or TH or TT, right? All the three are correct. Then it is not a mutually exclusive event. Mutually exclusive event means if one event is happening, other event cannot happen. Okay. Now, I will not, as I already told you, I will not go deep into the theory. I will just tell you one problem. Concept of expected value. Why I am doing this here is this is important for you in decision making as well. Do you have decision making in your syllabus? J- One second, let me just check. Yeah, you have. Okay, you have decision making also. In decision making, you may expect a problem either for 10 marks or 15 marks. So, to do problems of decision making, yes, you have decision. See, if you do not have syllabus, you can download the program guide from the website. Okay. And Shalini, if you want any information on open narrative, I will tell you after the class. Whatever you doubt you have, you tell me. I will tell you after the class. Okay. For doing decision making, expected value is very important. How to calculate that expected value? You just see here. A company is hoping to receive payment from two outstanding accounts. It estimates that there is zero point 0.6 probability of receiving 1500 due from A and 0.75 probability of receiving 40,000 due from B. Two companies have to give the payment. What is the expected cash flow from these two accounts? When you want to calculate the expected cash flow, then you have to draw a table like this. Account AB, amount you are supposed to receive 15,000 and 40,000. Probability of getting 15,000 is zero point 0.6. Probability of getting 40,000 is 0.75. Expected value will be amount into probability. Expected value will be amount into probability. Amount into probability is 9,000. See the same formula you have to use in decision making also. You have to multiply the amount and into probability. That means you are getting an amount of 9,000. This is the assumption. And in the account B, 40,000 you are supposed to receive. Probability of getting is 0.75. So it is 30,000. So totally you will be getting 39,000. You can have an expectation that you can get 39,000 from these two accounts. Okay, next we'll see binomial distribution. The binomial distribution is also known as Bernoulli distribution. Why that name is given? The name is given in the honor of the Swiss mathematician Jacob Bernoulli, who has derived this. Here we are using different terminologies. P is the probability of success. Q is the probability of failure. As I told you, this P and Q are mutually exclusive event. If it is success, then failure cannot happen. If it is a failure, success cannot happen. R is the number of ways in which we get success out of n trials. That means to say, suppose you have, for example, 5 red ball and 3 white ball in a box. You are having 5 red ball, 3 white ball in a box, and you are supposed to pick up one ball. What is the probability that the ball is red in color? When you have such question like this, you have 5 different chances of picking up 5 different red balls. So the probability here is 5 by 8. 5 by 8 because you have 5 favorable results. Total number of choices is 8. There are 8 balls in the box and you can pick up any one of the ball. In that case, The number of ways in which we get success is 5. That is R value. N is number of trials. In now I am doing it in one chance. I am asking you to pick up one ball one time. If I'm asking you to pick up two balls, then number of trials will be 2. Okay, this is how we use the formula. The formula here is NCR q to the power of n minus r into p to the power of r. This is NCR stands for combination. I think you remember having studied permutation and combination in your high schools. So let us take an example. Find the chance of getting 3 success in 5 trials when the chance of getting success in one trial is 2 by 3. Now here n is 5 because number of trial is 5. Okay, r is 3 because chance of getting 3 success. So r is 3. What is p? P they have told you it is uh, 2 by 3. This is the probability of getting a success is 2 by 3. What is Q? Q is equal to 1 minus P. That is 1 minus 2 by 3 equal to 1 by 3. Now you substitute this in the formula. When you substitute this in the formula, C to the NCR Q to the power of n minus r into P to the power of r, you will be getting an answer of 0.329. When you solve this, you get the answer as 0.329. So you have to remember this formula and you can find out answer to the probability distribution using binomial distribution. I'm just doing one problem of each type because I don't have much time. So I'm just doing one problem. You try to solve many more problems. Next is normal distribution. This is very important, even from the subject point of view, your examination point of view, and even future use also. Wherever you are making use of distributions, wherever you are making use of statistics, you will be using normal distribution. This is the more popular distribution of continuous random variables. As I told you, continuous means it can take any value within the range given to you. It was first described by D. Movidi in 1733. Then it was elaborated in 1812 by Laplace. It describes some natural phenomena. I'll tell you what it is. More importantly, it describes the sampling characteristics of totals and means. There are theory part, characteristics of normal probability distribution and all. I'm not going deep into that, but I'll tell you few of the characteristics. Before that, let me tell you what normal distribution is. Normal distribution, as the name suggests, is the normal way of distribution. When you take up any distribution, it follows a normal shape. What is that normal shape? That normal shape is a bell shape. You can see a bell shape here. Normal distributions are recognized by their typical bell shape. What is the meaning of this normal distribution is, say for example, if I ask you to make a chart of students of for example, I conduct a test for the students for 20 marks and I make a chart of students scoring different marks. So number of students who have scored 20, will it be more or will it be less in general? Number of students scoring 20 out of 20, will that be more or will that be less in general? Normally less, right? In the same way, number of students who score 1 mark or 2 mark, how many students would have scored 1 mark or 2 mark in a test? Will that be more or less? How many students would have scored 1 mark or 2 mark? Will that be less or more? Yes, it is also less. What about the number of students who have scored, say, 11, 12, 13, 14, 15, like that. Is it less or more? Number of students who score 11, 12, 13, 14, 15. Yes, it will be more. More number of the students would have scored 12, 13, 14, like this. So when I draw a graph, I can see number of students who have scored 1, 2 is less. When I go for 5, 6, 7, 8, it will slowly start increasing. When I go to 11, 12, 13, 14, it will be at the peak. When again I say 16, 17, 18, it will come down. Okay. This is the normal pattern followed by any distribution. Hence, we call this as a normal distribution. It has a single peak. Okay. It will not be in a uh, shape like this. I don't know whether if I move the cursor, you cannot see. I know. Okay. It is has only one peak, and it is unimodal means only one mode will be there, and mean will be at the center. The center line is always the mean line, and it is symmetrical means if if you draw a line here, a vertical line here, both the sides are same. And in the normal distribution, mean is equal to median equal to mode. And the last is the two tiles extend indefinitely. Here you can see the line has touched the x-axis in both the case. When we write normal distribution, it may not always touch like this. Of course, in all the figures I have written here, it is touching. But in general, we say it will not touch. That means to say, there can be a complete exception when it will be over. Say, for example, you are conducting a 100-meter race. How much time people will take to run this 100-meter? Some may come within 10, 15 seconds. Some may take 1 minute. Some may take 2 minutes. Some people may take 1 hour also. Right? So that value may not come here. So the line may not touch the x-axis. Okay. Now, let us do the problems here. To do the problem, first of all, we will be having some assumptions. One of the assumption is area under the normal curve is 1. Area under the normal curve is 1. That means the probability of scoring the marks in a test conducted for 20 marks, the probability of getting the marks is somewhere here only. Right? All the students are included in this graph. So it is 100%. Hence, we call area under the curve as 1. For all calculation purpose, area under the curve is considered as 1. Normal distribution has two parameters. One is expected value, we call it as mu, and other one is standard deviation called sigma. Okay. So the middle line is called as the mean line. That is the x bar line. Okay. Expected value mu is different. X bar, the actual mean is different. Sigma is the standard deviation. Now, you might have learned about Six Sigma. You might have heard about Six Sigma. According to Six Sigma, say for example, if I draw a line here in the middle line, it is called X bar line, mean line. There is an assumption that 68% of the total population will be within plus or minus 1 sigma. Okay. 95% of the total population will be within plus or minus 2 sigma. 99.7% of the population is between plus or minus 3 sigma. Okay. If you add this, plus or minus means this side 3 sigma, that side 3 sigma. Total it is 6 sigma. 99.7% of the values comes under 6 sigma. Is it clear? Or you need some more explanation on this? Do you need some more explanation or is this clear? Okay. See here. For example, let us take the uh, earlier discussion that the marks scored by the students. We have conducted a test for 20 marks, and let us say there are 50 students are there, and I take the marks scored by each student. Okay. Then let us say I find out the mean value. Let me say the mean value is 12. So if at all I have to write, I think I should write that in the YouTube only. One second. Otherwise, it is I can't write anywhere in this. Okay. Let me just try whether I can share a screen. Yeah. Okay. Now let me say mean equal to say 12 and standard. Say for example, I am conducting a test for 50 students for 20 marks. Okay. And I get answers like somebody is 12, somebody 13, somebody 15, somebody 9, somebody 8, like this. Mean is say 12. Standard deviation is say 2. Right? You can see what I am writing here, right? In the word file. Can you see what I am writing in the word file? Okay. Now, plus or minus 1 sigma means 12 plus 2 equal to 14. 12 minus 2 equal to 10. So, according to the formula of normal distribution, 68% of the students would have scored marks between 10 to 14. Out of 50 students, 68% of the students would have scored marks between 10 to 14. If I take 2 sigma, means 2 into 2 equal to 4. So 12 minus 4 equal to 8. 12 plus 4 equal to 16. Now 12 minus 4 is 8. 12 plus 4 is 16. Now 95% of the students would have scored marks between 8 to 16. 90% of the students would have scored marks between 8 to 16. Now, If I take 3 sigma, means 3 into 2 standard deviation equal to 6. Now 12 minus sigma, 3 sigma is 6. 12 plus 3 sigma is 18. Now 99.7% would have scored marks between 6 to 18. This is the meaning of the normal distribution. Okay, is it clear? So in the companies, they want to achieve 6 sigma, means they want to see that all their 99.7% of their items are error free, no defective. This is 6 sigma. Okay. Okay. Now again the problem is sharing the PPT. Okay, fine. Now, now how to find out the normal distribution? For this, the formula is x bar minus mu by sigma. Z equal to x bar minus x minus mu by sigma, where x is the normal random variable. X is the normal random variable. See, if you refer different textbooks, they may use, in some textbooks, they may use x bar minus mu by sigma. In this formula, they have used x minus mu by sigma, where they call mu as the mean, x as the random variable. In some textbook, they will call mu as the random variable and x bar as the mean value. Okay, and you, the corresponding table value is taken from Z. Yesterday, I have shared a table with you, and I asked you to take a printout of it. Have you taken the printout of it? Have you taken the printout of the distribution table which I shared in the group yesterday? Okay. This is the table which I shared in the group yesterday. Now, let us do a problem. Usually, you get this type of problem minimum for 10 marks. It is very easy, very simple formula, and you have to see the table. And the one thing which is very tricky here is that to decide. You are supposed to write a graph for this. How to write the graph is very important. See, an average light bulb manufactured by Acme Corporation lasts 300 days with a standard deviation of 50 days. Assuming the bulb life is normally distributed, what is the probability that the Acme light bulb will last within 365 days? Read the question again. The thing here is that you have to understand the question very correctly. If you understand the question very correctly, then it is very easy for you to solve the problem. The average light bulb manufactured by Acme Corporation lasts 300 days with a standard deviation of 50 days. Assuming that bulb life is normally distributed, what is the probability that Acme light bulb will last within 365 days? Okay, if you say less, then it is not the answer. You have to tell the exact probability in number. Okay, now what is the data given to you? Can anyone of you say what is 50 here? What is 50 here? Yes, 50 is the standard deviation. It is given clearly, right? With a standard deviation of 50 days. 50 is the standard deviation. What is 300 here? What is 300 here? Standard deviation is 50. What is 300? Yes, 300 is the mean value. Average means mean, right? Mean is nothing but the average. So the average time is 300. So mean value is 300. Okay. What is Anita? You are right. It is Anandish. It is mean. Okay. And what is 365 days? What is 365 days? Mean is 300. Standard deviation is 50. What is 365 days? Not middle value, not normal value. Yes, it is random variable. In the examination, they may ask you 365 or 370 or 350 or 300, 200, 100, whatever. So it is the random variable. Okay. Now you apply the formula z equal to x minus mu by sigma, right? That is 365 minus 300 by standard deviation. You get 1.3. 365 minus mean value 300 divided by 50, that is 65 by 50, you get 1.3. Okay. Why frequency? Where it will come here? Okay. Now understand, listen carefully and understand. The important thing here is that not getting this value. This is very simple, right? Expected value minus mean value divided by standard deviation will give you the z value. What is required here is the 1.3 whatever you get, how to get this value from the table. For this, you are supposed to write a graph. Just see the graph I have written here. This is the normal distribution. This center line is always mean line. So it is 300. And next is 360. You have to see, depending upon the value, whether it comes to the right side of your mean value or to the left side of the mean value. Okay. So 360 is more than 300. Hence, it will come to the right of the 300. So I have made a line on the right side somewhere, not necessarily here, anywhere on the right side, and I have shaded this much area. Now we are interested in calculating the area of this shaded area. What is the area of this shaded area in the graph? This is what we have to find out. Okay. Is it clear? I will tell you, I'll come to this later. First of all, you have to understand the problem and then you have to write the graph. Say, for example, based on the question, you have to write the graph. Sometime they will ask you more than the observed value. That means in this problem, instead of asking what is the probability that the Acme bulb will last within 365, you have to see the problem very carefully. Instead of this, if they have asked you what is the probability that Acme light bulb will last more than 365 days, okay, you have to understand the question correctly. What is the probability that the light bulb will last more than 365 days? More than 365 days means you have to take this area. If this is 365 line, more than 365 means this area you have to take. Less than 365 means this complete area. See, when a question is asked to you, what is the probability that the Acme lash bulb will last within 365 days means it includes probability that the bulb will last within 300 days, or the probability that the bulb will last within 200 days, or the probability that the bulb may last within 1 day also. Within 365 means this is 1 to 365. All these dates are included here. So I have shaded this complete area. When if I ask you more than 365 means I have to add this. Less than means only this much I have to show. Sometime they may ask you what is the probability that the bulb will last within 100 days. This is the mean line for 300, which is of course not shown. Less than, suppose this is the 100 line. This is the 100 line. Less than 100 means you have to shade this area. Okay, please understand I am speaking only about the shading of the area. Less than 100 means you are going to share. Now, one more question they may ask you, more than observed value means what is the probability that the bulb will last more than 100 days? More than 100 means 100 to infinity days, right? So this is the 100 line, this is the 200 line. I have shaded this complete area. Okay, this is very important for you. This is very important for you to know which area you have to shade. Okay, now coming back to the problem. Okay, now you open the table. What table I have shared? Just open the table and see corresponding value for 1.3. See here in the table you have two pages are there. One is minus values. Sometime you may get minus values also. Then you have to refer to this table. In case you get positive value, then you have to refer to the second table. And on the top of the table, you can read one thing, standard normal distribution, table values representing area to the left of the Z score. This line is very, very important. Area to the left of the Z score. That means if you are taking from this point, left of this area is given to you in the table. Since this is what we want here, we can directly take the table value. Got it? The table will give you from this point to this point. In this problem also our shaded area is same. So you can take it directly. Now, coming back to the table. One point three. What is a 1.3 value here? If you see the table, it is 0.90320. For 1.3, the value is 0.90320. So this value I have written here, 0.90320. That means there is a 90%, or you can even write 90.32% chance that the light bulb will burn out within 365 days. Okay. Now, for the same problem, if they have asked you, what is the probability that the bulb will last more than 365 days? In that case, I would have shaded this area, right? I would have shaded this area. Then Table value will give me this area. Understand properly. What I want is this area. If I take from table, it will give me this area. Then what I'm supposed to do is, whatever the answer I have got, I have to deduct that answer from 1. That means I have to write 1 minus 0.90320. In case they have asked me what is the probability that the light bulb will burn out in more than 365 days. Okay, is it clear? So when you are getting shaded area like this, that is more than the observed value, which is more than mean, then deduct the table value from 1. Okay, in the second case where the shaded area is towards left, you can take the direct value. If the shaded area is towards the right, then you have to deduct from 1. Similarly, based on the question, if they are less than observed value, means only this much you have. This is also from left it is, so take value directly. In this case, they have asked you more than this 100 or whatever, less than mean. So you are taking the right side value. Then you have to deduct the table value from 1. Sometimes they may ask you like this also. That is, what is the probability that the bulb will last from 250 to 350 days? What is the probability that the bulb will last between 250 to 350 days? 300 is the mean value. They are taking from this point to this. Then you have to calculate the area of only this much. How to calculate only this much area means you can calculate area from this point to this point, from the 0 point to the right end point. Then you calculate the area from 0 point to the left end point, deduct 1 from other. Okay, sometimes they may ask you only this much area. So in the red area, what you can see in the graph, then you have to calculate 0 to 4 area, calculate 0 to 3 area, deduct 1 from other. Like this you can do. Otherwise, you can find out this area plus this area will give you the area at the top. In any way you can do. Okay, any doubts? What you can do is you can do 1 or 2 problems on this. If you have any doubts, do different problems. One type of problem I have done. In some problem they will ask you more than 365 days. In some problem they will ask you 100 to 200 days, like this. Do such problem and you can send me in the telegram individually. I will see if you have any doubt, you can share it to me and I will tell you. Okay. Okay, any doubts, please tell me. Somebody was asking about open elective. Open elective will be sharing the open elective questions very shortly in 1 or 2 days. Don't worry, I will send the PPT. Okay, I will send the PPT. But open elective questions we will be sending you very shortly by next week. You can find the problems in that study material, and also if you go refer any textbook on statistics, There is a chapter on normal distribution. You can find problems there. You can also refer to the old question papers. I will share some old question papers now. You can refer that also. Okay. For open elective, study materials I think is uploaded to your app, and we'll be sharing the open elective questions. Maybe within 1 week we'll be sharing. Is subject okay? I will send the syllabus also in the Telegram. Okay, I will send the syllabus in the Telegram group. And seminars will be done subject wise only, of course. They will share the seminar timetable. Why do you worry? They will definitely send the timetable. Without timetable, they cannot do seminar. No, they will send us timetable. Wait, don't worry. Okay, anything else? Okay. Yes, deleted portions from the study material. You have from the first unit to till seventh unit, as per the study material you have. You can refer to the app. In the app, we have given the soft copy. In the soft copy, we have removed the deleted portion. Inventory management you don't have, and even the queuing theory I think you don't have. Queuing theory, no. You have game theory and then you have decision making, not queuing theory. Copies of seminars means what? There is no such copies. You are going to present one paper in each session. What is points paper? I don't understand. You have to speak extempo. Okay, maybe in the first semester we will allow you to refer to any papers, but once you come to the higher semesters you should be able to speak without any paper. Extempo you should be able to speak. Okay, I will share the question papers also. Whatever I have I will share. Okay. Okay, let me close the class. I think other class will begin soon. Okay, thank you.